So, Assalamu alaikum students, 40th lecture, chapter number 4, third of chapter number 4, third lecture of chapter number 4. What is the name of the chapter? Periodicity of elements. What will we do today? We will see the next topic, Mendeleev's periodic table. All right. So this chapter is all about the arrangement of periodic table. Okay? You know that what is periodic table? It's a chart of known elements. It's a table of known elements. It's an array of known elements. Right? So in this table, we can find what? The elements which are arranged in a systematic way. And what else? We have coined another term, periodicity. What do you mean by periodicity? The repetition of a phenomena. Like, as I gave you an example, that in school, colleges, we hear school bell, every after 40 minutes. So that's why we say the period is over. So what is periodicity? Repetition of a certain phenomena. Then we have studied that around 150 years ago, there wasn't any such concept of classification. So J.W. Dobrenier was the first one who gave the concept of grouping. What is the concept? Grouping. Means he observed that elements can be grouped together. He was able to make how many groups? 3 groups. And each group has how many elements? 3 elements. So he was able to make a group of 3 elements. That is why it is called triad. Dobrenier triad. What are the characteristics of that group? That all the members are same chemical properties. They have same chemical behavior. And the second point is, there are 3 elements. If you add the mass of the first and third and divide by 2, it will give you the mass of the middle one, as you can see on the screen in the example. What is the mass of, there's a group of calcium, strontium and barium. So if we add the mass of calcium, which is 40, and the mass of barium, which is 137, and find their average, 40 plus 137 divided by 2, then the answer is 88.5. This 88.5 is what? Is the mass of the middle one. So that is why it is discussed that in the group, the mass of the middle, the atomic mass of the middle element is the average or arithmetic mean of the other 2. Okay? So this is revision. Then what else? There was a scientist, Newland. What he observed? He observed that when elements are arranged in ascending order of their atomic weights, considering their atomic weights. I'm only talking to those who were present yesterday. All right? So, what was Newland's contribution? In front of Mr. Newland, elements were spread without any formation, without any order. So what he did? He arranged all the elements, all the then known elements in ascending order. Ascending order means he arranged the element from smaller atomic weight to biggest atomic weight. Okay? And when he arranged them, he came to know that the properties are repeating. He arranged the first element and second one, third one, fourth one, fifth, sixth, seventh. Then when he arranged the next element, the properties of the first are same. So what is the main point there? The main point is, if the elements are arranged in ascending order, then the properties of every eighth element would be same. Then there was another scientist, LOTHER. I told you that this one is the least important. Just follow on one point, that he plotted a graph. You know that when a graph is plotted, it is plotted between two quantities, x and y. So he plotted the graph between atomic weight and atomic volume. I know that it is difficult to understand this one especially. So when he plotted the graph, what was he observed? That this is the main point. Just try to understand it. What he plotted the graph between the two quantities, their weights and their volume. And he joined all the points, as you can see on the screen. What is the important thing here? He observed that elements with the same properties are occupying the same positions in the graph. For example, lithium, sodium, potassium, they all are similar in properties. So they are occupying the peaks of the graph. What was the point? He plotted a graph between their atomic weights and their volumes. He joined the points. What he observed, that elements having the same properties are occupying the same positions in the graph. Like lithium, sodium, potassium, rubidium, cesium, all are there at the top. Okay. Similarly, if you see that just below lithium, you can find beryllium. Just below sodium, you can find magnesium. Just below potassium on right side, you can find calcium. And then just below rubidium, you can, on right side, you can find Sr, strontium. So these beryllium, magnesium, calcium, strontium, they all have same chemical behavior. So what is the point here? What was you observed? You observed that elements having same properties are occupying the same position in the graph. Okay? Now this is today's topic. MENDELEEV'S periodic table. This is an important question, and the same topic would be repeated in grade 12's chemistry, right? And this topic, you can say that this is the base of today's periodic table. Correct? Means that the periodic table that we are using nowadays is based on his observations. Mendeleev was a Russian chemist. His full name is Dmitry Mendeleev, right? He published a periodic table after Newland, or you can say that he extended the Newland's periodic classification. Newland means law of octave. So that is why you can see here that Mendeleev's periodic table was the extension of Newland's law of octave. I repeat, Mendeleev's periodic table is connected with Newland's periodic table. And when was it published? It was published in 1869. What kind of table is this? This is Mr. Mendeleev. So first thing, as I gave you an example yesterday, what we did yesterday, I wrote so many elements on the board with the atomic weights. Then I arranged them in periodic table, in ascending order over here, right? Wait for a minute. So let's suppose I have some here. What am I doing? I'm writing some elements over here. Okay. So let's suppose these elements, these alphabets are representing what? These alphabets are representing elements. So let's arrange them alphabetically. First of all, obviously, A. Then obviously B, C, D, F, okay, then G, you can continue afterwards, C, D, E, F, G, H, I, J. Now next available is L. Okay. One thing, why I wrote H over here, why I didn't write over here, just recall your yesterday's lecture. Because the properties of H are very much similar to the properties of A. The properties of I is very much similar to the properties of B. The properties of J are same as that of C. Okay. Now the next available is L. When Mendeleev tried to write L over here, just below D, what happened? The properties of these two couldn't match. And the properties of L was matching with this one. So what he did, he left a blank space over here. This is the point that you should remember, that he put the next available element not here. Why? Because the properties of this one and this one are not matching, but it's matching with this one. So he put it over here. Then M. Okay. And the next available is P. Again, when he tried to write P over here, he saw that the properties of P is not matching with these, but it's matching with the next one. So he left a blank space over here. So what is the first point? That in Mendeleev's periodic table, he left some blank spaces. And according to him, he said at that time that elements would be discovered over here, and over here. He left 3 vacant places. He left 3 blank spaces for the elements to be discovered. Okay? I repeat, in Mendeleev's periodic table, he left certain gaps. Why? Because he assumed that here the elements would be discovered. And what else? Okay, let me tell you one thing. Suppose this one melts at 20 degrees Celsius. Just suppose this one melts at 30 degrees Celsius. So can you predict at what temperature this one will melt? 20, 30, 40. Yes. So same repetition, same trend was seen by Mendeleev. So he predicted the properties of those elements which were not discovered at that time. This is something very strange. An element is not there, but considering it scientifically, he was able to tell the properties of undiscovered element. And he told the properties of all of these elements, these elements, these elements. When he told these points to the other scientists, they said, what are you saying? How could you tell the properties of those elements which are not even there, which are not discovered, prepared yet? So what they did, they trashed off Mendeleev's periodic table. All right? Then what happened within 2 or 3 years? One more thing. They said, you have become mad. You are working lunatically. You are not a serious person. How could it be possible? You are telling the properties of those elements which are not there. Nobody has seen them. So they trashed his periodic table and sent them to the mental hospital. Then what happened? Within 2 or 3 years, these elements were discovered. And they have got the same properties as predicted by Mr. Mendeleev. Then everybody came and saluted Mr. Mendeleev and called him the father of periodic table. Right? Now, why Mr. Mendeleev was able to predict the properties of undiscovered element? Just because of periodicity. Because he observed a trend. He observed the repetition of property. He observed that if this is reacting with an acid, this is also reacting in acid. So this should also react with an acid. If this is producing carbon dioxide gas with an acid, this is also producing carbon dioxide, then this should produce carbon dioxide. So in this way, he predicted the chemical properties due to periodicity. Clear? So what is the main task here? What are the main points here? That Mr. Mendeleev arranged all the then known 56 elements. He published his periodic table 2 times. One with 56 elements, the other one with 63 elements. So he published his periodic table having vertical columns and horizontal rows. All right? And in his periodic table, he left certain blank spaces. And what was his thought? He predicted that some element would be discovered on these vacant blank spaces. Later on, his prediction came true. He even named those elements with undiscovered element. Like this one, he called them, as you will see on the screen, Eka boron, Eka aluminum. Eka means below. So here he had boron, B. So Eka boron means just below boron. Eka aluminum means just below aluminum. So in his life, element discovered. Gallium is the name. The element which was discovered afterwards, like gallium, has got the same properties as it was observed by Mendeleev. Okay, so here this is the extract. Now let's see. So what's written there? Mendeleev arranged the elements in order of increasing atomic weights into how many columns? 8 columns. And how many rows? Rows means periods. These are called columns or groups. And if you move from left to right, these are called rows or periods. So in Mendeley's period table, there are 8 groups and 12 rows. Okay? So what's written next? By doing so, he observed the repetition of properties with a slight change. He observed the term periodicity. Okay? So he gave a law that the properties depend on atomic weight. As I wrote here, its melting point is 20, its melting point is 30, its melting point would be 40. So as the weight is changing, the property is changing. So he linked the properties with the weight. And in daily life also, as the weight changes, activities changes. As the weight changes, activities changes. Same is true as we go from top to bottom. Then what happens? Like see this one. Suppose the mass of lithium is 7, the mass of sodium is 23, the mass of potassium is 39, rubidium, cesium, etc. So mass is increasing, the properties are also changing slightly. If this is less reactive, it reacts, suppose in 3 seconds, this will react with 2.5 seconds, this will react with in 2 seconds, this will react in 1.5 seconds, this will react in 1 second. So that there's a change in property as the weight is changes. So this is called Mendelev's law. This is written over here. The properties of elements are the periodic function. Periodic function means depend on their atomic weights. What are the 3 main points over here? Elements are arranged in increasing atomic weights into 8 groups and 12 horizontal periods. Second, he observed that the properties are changing little bit from as the weight changes. So he said the properties depend on atomic weights. Here is the table. This one is the original table. And you can see I've marked over here the 3 blank spaces over here. The 2 red ones, the 2 elements above the red circles, aluminium and boron. So you can say the first red circle is called Eka boron, and just below it Eka aluminium. You can see that there are 12 horizontal rows and 8 vertical columns. So these are the features of Mendeley's periodic table. It has 8 vertical columns, groups, and 12 horizontal rows, periods. Elements in each vertical column have same chemical properties. Just told you. Suppose it's a group, then all of them are having same, more or less same chemical properties. 3 vacant spaces were left for the elements to be discovered. He proposed their names: Eka boron, Eka silicon, Eka aluminium. Then in his life, These elements were discovered and they have got the same properties as discovered by, as predicted by Mendeleev. So the element which he called Eka boron, it has become scandium, Eka aluminum becomes gallium, and Eka silicon becomes germanium. Okay. Now, what are the advantages of Mendeleev's periodic table? You can say it provides scientific footing to study the properties of elements. Whatever the properties of lithium, because all of these are in the same group, in a group, means they are similar in properties. If this is producing something, for example, hydrogen gas, this will also produce, this will also produce, this will also produce. Okay? Intensity could be different. For example, as I told you, suppose in a certain reaction it is reacting in 5 seconds, then it is reacting in 4 seconds, 3 seconds, 2 seconds, 1 second, but the product would be same. So it helped in systematic study of elements. Prediction of new elements was made possible. And when he gave this periodic table, he corrected the atomic weights of certain elements. So these are the advantages of Mendeleev's periodic table according to our book. It's all written in the book. I have taken the same sentences from the book. Now, what are the drawbacks? First thing. So when Mendeleev gave this law, this theory, Mendeleev's classification, criticism was there. So people objected certain points. First point, at that time, what was the thinking? At that time, the thinking about isotopes was different. You know isotopes? Like atoms of the same element having same atomic number but different atomic masses. So at that time, they think that these are different. These are the isotopes of carbon having same atomic number but different atomic masses, right? So they thought that they are different. So they said, these isotopes are not mentioned in your periodic table, only carbon is written. Where are the isotopes? So he couldn't answer this question. Secondly, as there does not throw light on the position of isotopes. What else? It gives no idea about the structure of an atom. It didn't no discussion about why the elements are arranged like this, or no such sentence about the structure of atom. And what else? He made certain time he disobeyed his law. For example, in his law, what should be done? A smaller weight element first, heavier just follow. So at certain points, as you can see on the screen, he himself wrote a heavier element before a lighter element. Like you can see argon 39.9 is kept before potassium, which is 39. Reason? He didn't answer. And same is true. Different natural element like alkali metals, lithium, sodium, potassium are kept with coinage metals. Coinage metal means which are used metals which are used in making fines, like gold, silver, copper, etc. Has no proper place for lengthened, I can leave it. And what is the reason of all this? He couldn't answer. So, with drawbacks, we'll continue next. What is your homework? Nothing. Just do the self-practice test of Mendeleev's classification. That's all. Prepare your own notes. Next, modern periodic table. Okay? Take care. Thank you. Allah Hafiz.